Okay, we are here now. So, the more you guys talk in the back, the more I feel I have to raise my voice in the angrier that Mr. Gentleman in the front row gets, and I don't want that for anybody. So, can we pay attention, please? All right? So, when we last left off, we were down here. We basically figured out that if I had a 30-degree angle, right, the length of OQ, which was this bottom side, was root 3 over 2, and I figured out that the top side was 1/2. Okay? We are going to do the same thing, except instead of the initial, there's a stapler right there, Jesse. Instead of my initial ray being my content pictures, that doesn't have what I want. That's good enough. Now instead of my initial ray being at 30 degrees, my initial ray is at 45 degrees. So theta equals 45 degrees. Now, if my ray is at a unit length of 1, if the hypotenuse is 1 unit long, how long is this side? And how long is this side? What did we do? What did we find?
2 over 2.
Square root of 2 over 2, both of them, right? So the red is square root of 2 over 2. We'll call that x for right now. We'll call the green one y. And the green one is square root of 2 over 2 equals y and equals x. Okay? Number 2 is the same thing, except we want that first, or that initial ray, to be at 60 degrees. So now we're here, and our initial ray is 60 degrees. Again, my hypotenuse length is 1. I'll do the big side in green, small side in red. Small side is x, big side is y. And theta is right here. Theta equals 60 degrees. What is x in this one? What is my x value? Go back to the first page. What's that, Caleb? 1/2, right? So x equals 1/2. And y equaled what? Square root of 3 over 2. Okay. We're seeing a pattern here. All right, now we're going to say P is a point on the circle obtained by rotating initial A through 150 degrees. So, if I rotated my ray through here, I want to do that in blue though. If I rotated it through that far, how far would that be?
90.
That'd be 90, right? If I rotated it this far, how far would it be?
180.
All right, so 150 is going to be before this point or after this point? Before. So it's going to be about here.
150.
I'm going to put my ray right there. That's point P. And this distance right here is 1. And my theta, my angle, equals 150. So now, remember, my triangle now is here. So my my red is my x, and my green is my y. Now, what is my x?
-3.
Well, remember, if theta is 150, what do you think? I'm going to do this angle here again. What do you think that angle is? The one that I did too. It's 30 degrees, right? How'd you get that, Bailey?
150 subtract to 180.
Yeah, 180 minus 150, right? So, how tall is this side?
I'm lost. 1/2.
1/2, right? Y equals 1/2. What is my x?
Negative the square root of 3 over 2. Dude,
Why is it negative, Bailey?
because it's going the yay way.
It's going left, right? It's going left of 0. So x is negative root 3 over 2. Now, what is the name that I give to this x value in trigonometry?
Opposite.
Oh.
Adjacent.
So x is another name for cosine of theta. What do you think y is going to be?
Sine. That's whole.
Y equals sine of theta. Okay. We're jumping to the next. So now, exercises 3 through 5. We suppose that P is on the point of the unit circle obtained by rotating the initial ray counterclockwise through 120 degrees. Where is 120 degrees? Tell me when to stop. Tell me when to stop. Here, actually, I think I can do this better. Line, ray. All right. So, tell me when to stop.
Keep going. Keep going.
When do I stop?
Keep going.
Stop?
Oh,
What's that?
That's 90.
Is that 90? Keep going.
Whoa! Right there.
Okay. So if this is theta equals 120, what is this angle? 60. I'm going to call that, that. That's phi. That's phi. And phi equals, well, it equals 180 minus 120, which equals 60. Okay? But if the length of this ray is 1, ah, shoot, I didn't want that. I wanted this. So if the length of my ray is 1 and theta is 120, what is the length of x and what is the length of y? What is the length of x and what is the length of y?
Why is the thing up and down so
This is a different variable than this. Don't worry about it. You don't have to worry about this if you don't want to. It's just that green angle, this angle right here, equals 180 minus 120, which is this one right here. That's how you get the measure of that angle. I want to know what x and y are in this. So this is negative root 3 over 2? negative half. And this is? All right. And what's another name for y? Y? The other one? Sine. So y equals sine of theta, which equals root 3 over 2. X, wrong color again. X equals the cosine of theta. In this case, it's negative 1/2. Okay? And like we see, it lives in quadrant 2. Okay? We're going to do, that's exercise 3, right? So, sine of 120 equals root 3 over 2, and cosine of 120 equals negative 1/2. You get to do number 4, number 5,
You'll write stuff down or no?
and problem set number 1. Exercises 4 and 5, and the problem set number 1 due on Monday.